This video is actually just something that kinda interests me more than anything else, and really it's just talking about counting. Now, if I am counting, uh, what am I going to count? Well, specifically, I want to count the number of zeros in 100 factorial, just because it's an interesting thing to count. But how can we count that? The long and the short of it is we can't just use a calculator or anything of that nature and so-called plug it in and figure out what it is. We're actually going to have to do a little bit of thinking outside of the box, because if you put this into your calculator, it will just provide an error message. So we can't actually count going that route. So let's look at a smaller question first. And that smaller question is going to be, what is the smallest factorial that produces a power of 10? Or what is the smallest factorial that leaves a 0 at the end of the number? Well, let's kind of start off. And we'll start off with 1. If we do 1 factorial, that's just 1. If we do 2 factorial, that would be 2 times 1, which is 2. 3 factorial, 3 times 2 times 1, which is 6. 4 factorial, 4 times 3 times 2 times 1, which equals 24. And 5 factorial, which equals 5 times 4 times 3 times 2 times 1, and that is going to give us actually our first power of 10. Specifically, it's going to give us 120. So we have to get all the way to 5 factorial to get a 0 at the end of our number. Now, this brings the first thing that we need, and that is we need to think about what produces a 0 at the end of a number through multiplication. And that answer is, again, relatively straightforward. That answer would be that we have to multiply by 10. Well, if we have to multiply by 10, that means that we're doing really multiplying by both 2 and 5. Well, the one that's required in any factorial is a 5. Because essentially, we're always guaranteed to have a power of 2 once we get past 1 factorial. But we are not guaranteed to have a power of 5. To kind of get a better glimpse of this, let's write 5 factorial in its prime factorization. So we have how many 2's? Well, we have the 2 that's here, and then we also have 2 2's from our 4. So that's a total of 3 2's, 1 3, and 1 5. So we're going to have less 5's than we are 2's. So we don't need to count the number of 10's that are factors of the number. We don't even need to count the number of 2's that are factors of the number. Instead, we just want to count the number of 5's that are a factor of a number. Okay. Well, let's see if we can just do the easiest way to get 5 when we're dealing with 100, or figure out how many 5's are in 100. That would be 100 divided by 5, which gives us 20. Does this mean that there are 20 zeros at the end of our 100 factorial? Well, not necessarily. We need to investigate a little bit more. So, when will we get our next power of 5? So let's see about that. When exactly will that next power of 5 happen? Well, in order to get that next power of 5, we need to go up to 10 factorial. Because 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 factorial. We know that 5 factorial has 1 0 at the end of it, and 10 itself, factoring down into a 2 and a 5, is going to give us another 5. So how many 5's do we have now? We have 2 5's. Hence, 10 factorial would have 2 zeros. All right, this seems like we're going along a good way. So when we have 5 factorial, we have 1 0. When we have 10 factorial, we have 2 zeros. When we have 15 factorial, we will then have 3 zeros. 20 factorial, and we will have 4 zeros. But the question becomes, what about 25 factorial? Because 25 factorial is different from the others, in the sense that if we rewrite it like we did 10 factorial, we have 25 times 24 times 23 times 22 times 21 times 20 factorial. But 25 is giving us 2 5s. Okay. So 25 is giving us 2 5s, meaning that whereas, and I'm going to have to erase a little bit of stuff here. I'm going to erase right here just so we can organize ourselves a little bit. Our 5 factorial produces 5 to the first. Our 10 factorial produces 5 squared, 15, 5 cubed, 20 factorial is going to give us 5 to the fourth, and 25 factorial gives us 5 to the sixth. So we have 6 5s, meaning that 25 has 6 zeros at the end of it. Okay. Well, at this point, we have a good idea of what's going on, I think. We have our individual breakdown, and we notice that it took us 5 factorials to get to our first. It took us 25 factorials to get to our second, which is 5 divided by 5. So what I mean by that is it took us to 25 factorial to get another increase by more than just 1. We are now actually ready to do our counting. And we're going to do it very similar to what we were doing a second ago to start off with. And that was 100 divided by 5. And we know that equals 20. Let's look at 100 divided by 25. That's going to equal to 4. And if we then go 100 divided by 5 cubed, that is actually less than 1, because our 5 cubed being 125. So we're counting, but we're not counting by listing every possibility. Instead, we're counting by recognizing a pattern. That pattern being, if we are divisible by 10, we must be divisible by 2 and 5. And every 5th factorial gives us a new 5. Every 25th factorial gives us 2 extra 5s. Meaning, how many zeros, or what is the smallest factor or how many zeros are at the end of 100 factorial? Well, to put it simply, the number of zeros at the end of 100 factorial is 20 plus 4. I start off here, and I use this example for a reason. One, I wanted something to talk about, and counting is simultaneously the most basic mathematics there is, and also one of the most complex field of mathematics. Because a rule that almost all mathematics follows is don't work harder. Work smarter. Working smarter allows us to do things like how many numbers greater than 5,400, let's say, are divisible by 3. And contain unique digits. So let's put it this way. If you just ask me how many numbers greater than 5,400 are divisible by 3, I tell you there's an infinite number. But if you suddenly put this constraint on it, that it must contain unique digits, that changes the problem. I can actually count this number, but I'm not going to count it using I'm not going to count it by listing every possibility. If I want to count it, I'm going to have to think outside the box. But that will be a discussion for another time. For now, I hope that you have enjoyed this video, and I hope that you learned something.